Welcome to Math 1324, Math for Business and Social Science. We're going to start in Chapter 3, specifically with 3.1, and look at functions. Functions are an extremely useful way of describing many real-world situations in which the value of one quantity varies with, depends on, or determines the value of another. In this chapter, you will be introduced to functions, learn how to use functional notation, develop skills in constructing and interpreting the graphs of the functions, and finally learn how to apply this knowledge in a variety of situations. Well, we're really not being introduced to functions because functions are just a natural part of our life. Your body parts have a function. For example, your heart pumps blood, your lungs bring oxygen into the blood. Each of these has kind of is a system that takes an input, does something to it, and then has an output. And that's really our definition for a function here. We have three parts. The function is actually some kind of rule or equation, what is actually happening. We have an input, and specifically when we're talking about mathematical definition of a function, the input we're going to refer to as the x value, or when you think of an xy grid, the x value would be the input. All of the inputs together make up what we call the domain. Okay, so the domain is the set of all possible inputs. These go into a function, and then we have an output, which in math, again, we're going to call this the y value, or using functional notation, f of x. Note that both of these things, y and f of x, are the exact same thing. They are exact same thing. And the word range refers to all of the outputs, or all of the possible outputs. So let's look at an example. The amount of the electric bill you pay depends upon the amount of kilowatt hours consumed. The way in which usage determines the bill is given by the rate per kilowatt hour. This is an example of a function, right? So for example, the function might be the rate of pay per kilowatt hour. Maybe you spend 10 cents per kilowatt hour on your electric bill. Well then, what's the input would be the number of hours you used electricity. The function or the rule would be, 10 cents times x. So your electric bill, your y, your output equals 0.1 x, if indeed your electric bill was 10 cents per kilowatt hour. Okay, so your input is the number of hours you use electricity. The rule or equation is the rate of pay times x in this example, and then the output is what your electric bill would be. Okay. Let's look at another common function, calculating a paycheck, and probably most of you are familiar with this. So let's assume you work at a barista at Starbucks, and you make a wage of $10 per hour. And we might say that Starbucks has a rule that baristas cannot work overtime, which means you cannot work more than 40 hours. You cannot, it really should say less than or equal to 40 hours. So our input here, our function is going to be calculating pay. Our input will be the number of hours worked, and our output will be our paycheck. Okay? So again, thinking of this in terms of mathematics, our x value is the number of hours worked, as we can see there. That's the input. Our domain for the input is x has to be greater than or equal to 0 and less than or equal to 40. Now, how do we figure this out? Well, first of all, we cannot work a negative number of hours, and that's often true in a function, so you have to think about what's going on. And then we also had the rule here that we're not allowed to have overtime, so we can only work up to 40 hours. So these are the possible values of x that we can put in. Our rule is 10 times the number of hours, okay? Or as we'll see here, y, which again is the same thing as f of x. F of x is just saying a function with x as the input. This is just notation that you need to know for this course and going forward. F of x. It just means the same thing as y, and this would equal 10x. This is giving our rule and our output. Okay. Now, how do we find the range, all the possible outputs? Well, notice we have the possible inputs. They go from 0 to 40. And we know that the rule is y equals 10x. So 10 times 0 is 0, and 10 times 40 is 400. So our output range is from 0 to 400. Okay? And what we did there is we found the domain, we found the domain, plugged those values into the formula to find each end. Okay? The specific definition of a function mathematically is as a rule by which each input determines exactly one output. Now this kind of makes sense if you think about it. If you go to a gas pump and you're pumping gas, you don't want your gas pump to act like a slot machine at Vegas. What I mean is today you pump in 10 gallons and it costs, $20. Tomorrow you pump in 10 gallons and it costs $300. So that's the idea here, that every time you put the same input in, you should get the exact same output and only one output. And that's what this means here. I put 10 in, the gas price hasn't changed, I should always get the same output. So a function has consistency. Consistency is key. Each input produces a single output. You cannot put 10 in and get 10 or 20 out, because then you wouldn't know what to pay. But notice different inputs can produce the same output. Maybe an example, again, using cost would be that maybe for, think about internet usage. So for the first 5 hours of internet usage, it's a flat fee of $20. But every hour above that is an extra $5, let's say. So if you only were using internet for 1 hour, it would cost $20. Input 1, output 20. If you use the internet in the example I just said, for 2 hours, you'd still get 20. 3 hours, 20. 4 hours, 20. 5 hours, 20. As soon as you hit 6 hours, it would go up to 25. 20 for the first 5 hours, and then 5 for each hour after that. Okay? So notice those first 5 inputs, 1, 2, 3, 4, 5, all had the same output. Okay? So we say that a function follows what we call seesaw. The same input gets the same output every time. So if you have the same input and it creates the same output, seesaw, that's a function. If you have pseudo, the same input gets different outputs or more than one output when you put it in, then you do not have a function. And that's what this means here. It's not a function. Okay? This follows the definitions of a function. Okay? So let's try to think about this. Which of the following rules describe functions? You use the optical reader at the checkout counter of the supermarket to convert codes to prices. So when you're at the checkout counter, let's say you buy 3 cans of soup. They're all the same soup, tomato soup. Well, you would expect that each can is going to, when you scan it, it's going to have the same output, right? First can, $1.20. Second can, $1.20. Third can, $1.20. So this is an example of seesaw. Same input, same output. Put a can in, get a can out. So this is indeed a function. A is indeed a function. You enter a number into the calculator and you press the square key. Okay? If I put 4 in and I hit square, I get 16. If I put 4 in again, I hit square, I get 16. Notice if I put -4 in, and hit the square key, I also get 16. But that's okay, because those are different inputs. Different inputs can have the same output. Seesaw and deesaw are okay. Seesaw and deesaw, different inputs, same output, is okay. So this again is a function. Now this table is another way of looking at it. Okay? So remember, the x's are our inputs, the y's are our outputs. Okay? So we have, when we put in 1, we get 3. When we put in 1 again, we get -3. Notice what we have here is pseudo. Same input, but different outputs. This is not a function. Pseudo is not a function. Same input, different output. And the last one, D, here if the input is any number, then we can do equation. So if I put 1 in here, 3 times 1 minus 5 is negative 2. If I put it in again, I'm going to get negative 2. If I put 2 in, I'm going to get 1. So every time I put an x value in here, I'm going to get a 1 and only one value of y. So indeed, this is also a function, because when I put that same number in, si, same in, I get the same out. Same in, same out. So this last one is also a function. Okay? This is example 6 from your text, and I specifically put this in here, and I want you to see these icons. When you're in your text inside of My Math Lab, if you click on it, if you're in section 3.1 and you're at this example 6, these tell you that there's a video that you can watch that will help you understand these problems. So I wanted you to see these icons and use them when you're in the text. So what about A? Y equals negative 4x plus 11. Is this CISO? Same input, same output, which makes it a function. Or CIDO? Same input, different output, and it's not a function. Well, every time I put 1 in here, I get negative 4 plus 11, which is 7. I'm going to get the same thing. So this is indeed a function again, because every time I put the same thing in, I'm going to get the same value out. For a given value of x, calculating negative 4x plus 11 produces exactly one value of y. For example, if x equals negative 7, then y equals negative 4 times negative 7 plus 11 equals 39. Because one value of the input variable leads to exactly one value of the output variable, the equation defines y as a function of x. So this is indeed a function. Now let's look at B, y squared equals x. Okay. So let's think if x is 25. What would y be? Because remember, x is the input. So if x is 25, y squared would be 5, right? But notice also, if x is 25, we could also have y be negative 5. Negative 5 squared is also 25. So in this case, we could have two different outputs for that same input of x equals 25. Okay? So this is indeed not a function. And here's the same example with x equals 36. So y squared equals 36, from which y equals 6 or y equals negative 6. And since we have more than one, since one value of x can lead to two different values of y, this equation does not define a function. Now remember that the domain is the set of all possible inputs, all possible inputs. Since this is usually a large group, it's usually easier to figure out what is not possible. Okay? So when you're looking for the domain, sometimes it's actually easier to figure out what's not possible. Remember in the last example with Starbucks, we know that we couldn't work negative hours, so we knew we started at 0 and we were limited to 40 hours by management. So by figuring out what was not possible, we could then see what the domain was. Okay? When dealing with equations as functions, so when you're looking at a mathematical equation and trying to figure out the domain instead of an example like the Starbucks, there are two types of equations to keep in mind. The first one are rational functions. And remember, rational functions are ratios, which is a fraction, a function over a function. Okay? And remember, with fractions, you cannot have a 0 in the denominator. So the way you figure out what's not possible is you set the denominator not equal to 0 and solve. Okay? So in this case, also notice if we have square roots, which is kind of what we did in the last example, y squared equals x. We could have said y equals the square root of x. Okay? And remember, with even root radicals, this means a square root, a fourth root, a sixth root, not a cube root, not a fifth root, but an even root. Remember, even roots can only be taken a positive number. So for example, the square root of, you cannot take the square root of negative 25 because no number times itself will equal a negative number. Negative times negative is positive, positive times positive is positive. So All the roots, whatever's inside, has to be positive. And so we set the radicand, that's the inside part, greater than or equal to 0 and solve. So when we set the denominator equal to 0, we get x cannot equal negative 5/2. So the domain of this first function is everything but x equals negative 5/2. In the second one, when we set this greater than or equal to 0, x plus 2 is greater than or equal to 0, we get x is greater than or equal to negative 2. And this automatically is indeed the domain. This is what is not in the domain, so you have to be careful there. Here we have example 7. Each of the given equation defines y as a function of x. Find the domain of each function. Y equals x to the 4th. Okay. What possible numbers of x can I put in here that will give me always a one answer, the same answer on the output? Well, here I do not have a rational equation. I don't have a fraction. I don't have a root in A either. So in this case, it's all numbers because I can put any number in there. I can put x equals 2 and I will get 16. 2, 4, 8, 16. I can put x equals negative 2 and I get 16. I put 2 in again, I get 16. So I can put any number of x in here. Notice this is not a radical equation, and it's also not a fraction. So when they're not either, it typically is all numbers. And we write this as negative infinity to infinity. In B, we have an even-rooted radical. So this is when we set it the inside, the radicand, greater than or equal to 6. When we do that, x minus 6 is greater than or equal to 0, and solve for this, we get x is greater than or equal to 6. Using interval notation, which documents a number line, this is answered as square bracket 6, comma, infinity, parenthesis. Okay. We use the square bracket because we are including the value of 6, greater than or equal to. If this was x greater than 6, it would be parenthesis 6, comma, infinity, parenthesis. Let's continue on. In D, we have a rational expression. So we set the denominator not equal to 0 and solve. So we know that x plus 3 cannot equal 0. If we solve that, x plus 3 does not equal 0, we get x cannot equal negative 3. And so x is everything but negative 3. So again, think of this interval notation as documenting the number line. We go from negative infinity, comma, negative 3, or you can put a union here too, a big U, from negative 3 to infinity. And notice these are all parentheses because it does not include negative 3. We don't go to negative 2 and then negative 1. The parenthesis tells us we go all the way up to there but do not include it. Okay? In E, you're going to have to use some of your hopefully prior skills about either you're using the quadratic equation or factoring. In this case, we're going to factor this. This is a trinomial, and you should know how to factor this. Okay? If I factor that equation, I set the denominator equal to 0 or not equal to 0, either way. If I factor x squared minus 3x plus 2, I get x minus 1 times x minus 2. And remember, if anything times something else equals 0, then this is true if either of these equals 0. So I use the zero factor property and set each factor, each multiplier, to equal to 0 and solve those. So I get x equals 1 or x equals 2. Okay. Now remember, these are values that are not allowed because the denominator cannot be 0. Therefore, and also notice, oh, this was a tricky one. I even missed that part. I was going to say x can be anything but 1 or 2. But notice in the numerator, we also have an even-rooted radical. That one slipped right by me. And remember, this has to be a positive number. So the numerator has to be greater than or equal to 0. The denominator can be anything but 1 and 2. So we have to use both of those. So our whole domain is a positive number, any positive number, 0 or positive number, except for 1 and 2, because 1 and 2, remember, turn the denominator into 0. In actual practice, functions are seldom presented in the style of domain, rule, range, as they have been here. Functions are usually denoted by a letter such as f. If x is an input, then f of x denotes the output number that the function f produces from the input. All this is saying, it's a lot of words, f of x is the same as y, okay? So don't get confused. The symbol f of x is read f of x. The rule is usually given by a formula, such as f of x equals the square root of x squared plus 1. This formula can be thought of as a set of directions, okay? The name of the function, and we usually use a letter that's related. So if this was the profit function, we might have p of f. If it was a function of height of children over time or at age, it might be h of x, okay? The input number or variable is inside the parenthesis, and the whole value f of x represent the output. And you get that output by putting in values into the formula. The directions or rules that tell you what to do with the input x in order to define it. Here we have to square it, add 1, and then take the square root of the result. Note, this is exactly the same as y equals the square root of x squared plus 1 if we were graphing. Okay, so I want you to see this, and I want you to get this in your head. Y and f of x are really kind of the same name, different names for the same thing. F of x and y is the same thing. Okay, f of x and y is the same thing. All right, so how do we calculate function values? Again, remember that we have the name of the function, we have whatever the input variable is, and then we have a formula. Okay. So for example, to find f of 3, since f of x equals the square root of x squared plus 1, notice as soon as we want to find f of 3, this means that x is 3. X is 3. So wherever we have an x in the rule or the formula, we're going to plug in 3. So f of 3, instead of equaling the square root of x squared plus 1, equals the square root of 3 squared plus 1, because in this example, x is 3. And then we just do the math and we get the square root of 10. Okay? Similarly, the output f of c of 4, now this is what's happening here is we're replacing one variable with another, which is a little bit confusing. This is when we do complex functions. This is corresponding to the input of c4. So don't get overly worked up about this or overthink it. All we're going to do is wherever we had an x, we are now going to put a c to the power of 4, and notice we're putting it in parentheses. Okay? So c to the 4th squared means c to the 4th times c to the 4th, which gives us c to the 8th plus 1. And this is following the order of operations. We do what's in parentheses first and then exponents. So we can simplify this without worrying about the plus. Okay? See if you can calculate f of negative 5 and f of 0 using the same formula. Okay? Hit pause now and see if you can do that, because I'm going to move on and give you the answers. F of negative 5 equals the square root of 26. Did you get that? And f of 0 equals the square root of 1, which is just equal to 1. Okay? Let's solve some more now. Again, I suggest you hit pause, see if you can do these, and then hit play again. So notice I have my formula here, g of x. Notice I can use any letter here, equals negative x squared. Now be careful here. Remember that you do exponents before you do multiplication. So this is x squared, square it first, and then multiply times negative 1, plus 4x minus 5. So let's go through these, okay? G of negative 2 equals negative minus 2 squared plus 4 times negative 2 minus 5. Notice there were two x's in our formula, so everywhere there's an x, we've replaced it with negative 2 in parentheses. When we do the math, we get negative 17. Now this is a build-up, and this is actually how you will solve the difference quotient, which is important for calculus. If you're taking business calculus later, you'll need this. What we're going to do is we're going to build up the parts. Notice here we're building each piece. This is the first piece, the second piece, or the whole numerator is the second piece, and then we're going to do the third. Okay? So here, wherever we had an x in the original equation, we're going to put x plus h in parentheses. So we have negative on the outside, remember that comes after, x plus h in parentheses squared, plus 4, there's another x there, so we have x plus h. We're plugging in this whole thing, x plus h, where there was an x before, and now we're doing the math. Here we have to FOIL. This is not x squared plus h squared. This is a FOIL. You need to know how to FOIL. If you don't, go back in and do some review. So I get negative, again on the outside, x squared plus 2xh plus h squared, plus 4x, this is distribution, do your bunny hop, 4x plus 4h minus 5. Kill trees in this class. Take your time. Do not try to jump through multiple steps at once. You'll make mistakes. Then we multiply negative times all of these, so every one of these, since they're positive, becomes negative. And so this is g of x plus h. Okay? This next one says g of x plus h minus g of x. Now, whenever you're subtracting a formula, whenever you're subtracting something, it's a good idea to put whatever you're subtracting in parentheses. Okay? Why do we do that? Because otherwise we will forget to change the sign of each of these. I'll often see that students will change the sign of the first term and forget that it's also minus a positive 4x, which is minus 4x. Minus a negative 5 is plus 5. And so this 5 and the negative 5 cancel out. This plus 4x and negative 4x cancel out. This negative x squared and this positive, negative, positive x squared cancel out. And I'm just left with this. Okay? So this is g of x plus h minus g of x, and I get this as a result. The last thing I'm going to do is plug this in all over the denominator of h. Well, we've already done the top part, which is here. Okay? Now be careful again here. A lot of students will try to cancel out this h and just one of these. You cannot cancel h out of, for example, negative 2xh because there's multiple terms here. When you cancel out something, you're dividing by that, and h over h equals 1. But you cannot cancel out h over something minus something or something plus something without taking it out of all of them. So notice the first thing we can see is that there is an h constant in each term, so we can factor it out. So we're changing the numerator by taking out an h from each term. If you do the distribution, you'll see we get back to this denominator or numerator up here. Now, since this h is multiplying times all of this, and we're dividing by h, now we can cancel it out of that 1. Because canceling out, dividing by, cancels out multiplication. It does not cancel out subtraction. It does not cancel out addition. And so our final answer here is negative 2x minus h plus 4, because h over h is 1, and those cancel out. So this is our last problem for here. This is a word problem, and most of this course, a lot of this course is word problems. So this is example 9 in your book, and you can again go in there and maybe see a video. If you are a single person in Connecticut in 2013 with a taxable income of X dollars, and X is less than or equal to $500,000, then your state income tax was determined by the rule T of X. This is called a gosh, I just lost my blank. T of x has multiple values. This is, gosh, I'm sorry, I can't think of the word, what this is described. It's a function that has different formulas for different values. So we use the top formula if our input is between $0 and $10,000. And remember that our input is our taxable income. So if you made between $0 and $10,000, you pay this much tax. If you made between $10,000 and $500,000, you have to use the second formula. This is a piecewise function. That's the word I was looking for. So when you have a piecewise function, a function equals more than one formula, you have to start from the back. Okay, and what that means is, for example, in A here, are we going to use the top formula or the bottom formula? Which value is, if x is 9,200, notice that fits in the top formula, so we're going to use this formula to solve for A. And we get 276. For this piecewise function, if our income is 30,000, notice we use the bottom formula. We don't plug it into both, we use one or the other. So when we plug 30,000 into the bottom function, you can use your calculator through here, we get $1,300. Okay? So that's the end of 3.1. Try your work on my math lab, and if you have any questions, please feel free to email me.